Hello, my name is Claire Felicity Miller, and the title of my virtual lightning talk and paper is Towards a Photonic Textile Integrated System to Improve Operator Productivity and Comfort. Interdisciplinary Textile Design Knowledge in the Development of Smart Textiles. The project highlights a workstream within an interdisciplinary project that took place in 2018. The project was a response to a government-funded Innovate UK call in collaboration with Sellafield Limited that asked small businesses and academia to work together towards solutions that might improve the productivity and comfort of operators working in nuclear decommissioning environments. The group proposed to develop a range of smart basics to be worn as a base layer under a protective decommissioning suit to monitor vital signs of operators by using integrated photonic fibres. By detecting when an operator is beginning to overheat, early onset of heat stress might be identified and mitigated by quickly removing the operator from the environment, preventing not only heat stress but also common resulting rashes. Each project partner has a distinct expertise and had a clear role within the project, as you can see here. And the RCA textile design team focused on the integration of polymer optical fibres into textile structures. The RCA textile work package was guided by the following questions. What are the best methods for integrating optical fibres into knitted textiles? And what material characteristics and yarn properties offer most potential for structural integrity and wearability? The potential and optimal methods for integration were identified through a 2-day hands-on making workshop with textile design MA students, a literature review, and prototyping of knitted textiles with integrated polymer optical fibres. The workshop, hosted by the RCA Textile Design Programme, was supported by footfalls and heartbeats and explored heart rate monitoring polymer optical fibres. Students were asked to work in teams to consider how to best integrate the polymer optical fibres into textile structures while maintaining and maximising technical functionality. Comfort and aesthetic considerations, positioning on the body, and material and structural configuration, such as how might the sensors be held in a textile structure efficiently to avoid relative motion between fibres and the skin. Students were asked to bring their design and craft knowledge to the task, such as an understanding of aesthetics, material knowledge and understanding, and to build upon new knowledge that was being introduced by footfalls and heartbeats, who supported the students in their developing understanding of polymer optical fibres, their limitations, properties and potentials. The samples demonstrate physically how these two types of knowledge might come together and the interdisciplinarity required in their making. The literature provided a foundation alongside this workshop on which knitted prototypes could be built. While the relative inflexibility of the polymer optical fibres might lend itself well to a woven textile process, knitted textiles offer great flexibility due to the inherent stretch found as a result of the loop formation in the knitting process of the knitted textile structures, meaning that they are a good choice for textiles that are intended to conform to the curves of the body. Other observations from the literature include that for successful future work in this space, decisions will need to be made as to whether it's better to optimise the machinery or the polymer optical fibres themselves for better integration into the textiles. The polymer optical fibres should be integrated straight and held close to the body in order to prevent breakage and to gather robust readings. The majority of the literature focuses on the development of optical fibres for sensing and their applications. However, there is a lack of research on how we can most effectively and comfortably integrate them into textiles, highlighting a potential for design processes in this space. A series of knitted textile samples were produced in a 10-gauge Shimoseki industrial knitting machine, and yarn combinations that are both wearable and comfortable against the skin, as well as having particular moisture wicking benefits, were explored and utilised, as well as yarn combinations that could potentially offer a mechanism of integral support to the insertion of the polymer optical fibres within the samples, for example by reducing slipping and holding the fibre in place. Connections and channels outside, connections and channels out of the textile structure, and coupling mechanisms of the optical fibre light source were considered in the sampling process. To finish, here are some of our references. Thank you for listening to this talk, and I hope you found it interesting. If you have any further follow-up questions, please follow up with me via email. Thank you.